Welcome to this lecture on Newton's law of cooling presented by Mrs. Manimegalai, Assistant Professor of Mathematics, Department of Science and Humanities, Hindusthan Institute of Technology, Coimbatore. We will explore how the rate of cooling depends on temperature differences, delve into its formula, solve practical problems, and discuss applications in engineering and science. By the end, you will grasp its significance in thermodynamics and real-world contexts. Newton's law of cooling was formulated by Sir Isaac Newton in the early 18th century as part of his broader investigations into heat transfer and thermodynamics. Newton did not discover the law of heating directly but derived it from his observations and mathematical formulation of cooling phenomena. Next, what is Newton's law of cooling? Newton's law of cooling states that the rate of cooling of an object is proportional to the difference in temperature between the object and its surroundings. In simpler terms, the hotter an object is compared to its surroundings, the faster it will cool down. This cooling rate is governed by a specific mathematical formula. Next, the formula for Newton's law of cooling. T of t equal to Ts plus T0 minus Ts into e power minus kT, where T of t refers to the temperature of the object at time t. Then Ts is the surrounding temperature. Next, T0 is the initial temperature of the object. Then K is a constant of proportionality that depends on the object and its surroundings. In this slide, we will see a problem named as cooling a cup of coffee. A cup of coffee is initially at 90 degrees Celsius. The room temperature is 20 degrees Celsius. After 5 minutes, the coffee cools to 70 degrees Celsius. Using Newton's law of cooling, find the temperature of the coffee after another 5 minutes, that is at 10 minutes. Now we will find the solution. Step 1. Find the value of K. What are the values given in the question? After 5 minutes, the coffee cools to 70 degrees Celsius. That is, at time t equal to 5, T of 5 is 70 degrees Celsius. Using this value in the Newton's law of cooling formula to find the value of K first. After we got the value of K, to find the temperature of the object at 10 minutes. Now we will calculate T of 10. Again, by using the Newton's law of cooling formula, we get finally the temperature of the coffee after 10 minutes is approximately 55.71 degrees Celsius. Next, we will see engineering application one by one. First one, thermal design. Engineers Newton's law of cooling in thermal design to determine cooling rates for systems like electronics, engine and buildings. Second one, food processing. The food industry relies on this law to calculate cooling times for food products to ensure safety and quality. Third one, environmental monitoring. It is used to model the rate of cooling of lakes, rivers and the atmosphere, understanding environmental factors like temperature changes. Next slide, key takeaways. First one, rate of cooling. The rate of cooling is proportional to the temperature difference between the object and its surroundings. Second one, formula. The law is described by a simple mathematical formula. Third one, applications. Newton's law of cooling finds widespread applications in engineering, science and everyday life. At last, conclusion. Newton's law of cooling is a fundamental concept in physics that helps us understand the natural process of heat transfer. Its mathematical framework allows us to predict and control cooling rates, making it a crucial tool in various fields. Thank you for your attention. I hope this presentation has provided a clear understanding of Newton's law of cooling. Thank you.